All right. We're going to finish up chapter 4 here, talking about the real zeros of polynomial functions. What do we mean by real zeros? What do they mean? No, the x-axis. Their zeros are synonymous with solutions, x-intercepts, factors, roots. So this we're going to look at. We're going to look at where is it across the x-axis? What's the solution of it?
So what's what's it solving?
Because it's at what value of x will the y value equal 0? So, and that's the thing we look at. If you look at in engineering, so we start at the ground level. When is it going to come back to ground level? So what's the solution? When will the rocket? Well, back when Newton was doing all this stuff, when he was at his point developing calculus, when Leibniz was over there, what he was doing, he was looking at a field and he noticed that cannons were firing their artillery shells. And what he finally came up with is there's only one maximum trajectory that this cannon can have at a certain angle. That means anything else closer than that, there has to be two solutions. Because first off, it's a parabola. Now, the parabola could be short or it could be high. Militarily, because he was looking at the military practice of cannon fire. What's the difference between these two solutions? On different angles will give you the same solution point. Well, because if you shoot low, what's going to happen to the cannonball? It's now going to take out everybody behind it. If you shoot it up high, it makes a bigger explosion and a bigger footprint on the ground. So he was looking at this, but he was looking at that. That's why this is our solution. When will it reach the ground again at 0 level? Good question. So here's how we have. We're going to look at fractions in a little bit. When you look at a fraction, you have the numerator, the denominator, which is the dividend, the divisor, equals the quotient plus the remainder. The remainder is whatever you have is over the denominator. But now if we multiply both sides by the denominator, we get f of x equals q of x times g of x plus r of x, which is what we have up on top. So you have your dividend equals your quotient times your divisor plus your remainder. Here's a good. Now, why is it important? Here's the point that this first topic is going to talk about, the remainder theorem. Everybody okay with everything on top?
What did you do?
Right here?
Yeah.
I had this is my original equation. If I multiply both sides of this equation by g of x, the g of x cancels here, q times g, and it cancels over here. So that's what we have left. And that's what we have written up here. The reason, because anytime you have a rational equation and everything, when we solve them, we don't need to have a rational equation. This is not a rational equation. It can be written as a form of a rational equation. But the remainder theorem says this. If f of x is a polynomial function and is divided by x minus c, then the remainder is f of c. This is pretty interesting, this concept. If f of x is a polynomial function and divided by some binomial x minus c, then the remainder is the function f of c. Let's look what this means. So our function that we're going to deal with first is x cubed minus 4x squared minus 5. Find the remainder if your divisor is x minus 3 and then x plus 2.
Setting up a synthetic division problem.
Even easier than that. But yeah, actually, let's do that. Is everybody okay with familiar with synthetic division? Or I'll go review it anyway. But yes, let's look at it both ways then. I'm glad you asked that. So let's look at the first one. We have x cubed minus 4x squared minus 5 divided by x minus 3. To use synthetic division, what has to be the condition?
Don't they all have to be a divisible of that number?
Not really. But I see why you think if it was a perfect solution, yes. But in order to use it, there's only one condition we have to have. The denominator must be in the form x plus or minus c. X cannot have a coefficient. It cannot have an exponent. It has to be a linear equation. And since our denominator here is in that form, we can use synthetic division. Now, the first step, set your denominator equal to 0 and solve for c. So in our case, we have x minus 3, set it equal to 0, x equals 3. So this is my c value. Third, put your coefficients in the appropriate columns. So we have 3. This upside down division symbol, that tells you you're using synthetic division. Synthetic division does not use letters. It's only numbers. So the highest exponent is x cubed, x squared, x, and a constant. So what are the coefficients? They go down here. What's the coefficient of x squared, x cubed? X squared.
-4.
X.
Sure.
C.
Fine.
-5. Bring down the first term. Now it's a matter of multiplication, addition, multiplication, addition. So C times this, 3 times 1 equals 3. -4 plus 3 is -1. So it's multiplication this way, addition straight down. 3 times -1 is -3. 0 plus -3 is -3. 3 times -3 is -9. -5 plus -9 is -14. There is your remainder. Here's another cool thing about it. But first off, what does the remainder tell us?
Leftover.
Well, yeah, but what does it tell us about it? The remainder? If the remainder equals 0, then the x minus c is a factor of your polynomial. In other words, if you have a remainder of 0, that means x minus c is a factor, which means that c is an intercept. This means that c is an x-intercept, your solution. So that's what the remainder theorem tells us. If you have no remainder, that means it factors into the equation perfectly. But here's another cool thing. In this equation here, if I ask you to find this, you would have to go through all this. 3 cubed minus 4 times 3 squared minus 5. What is 3 cubed?
27.
27. 3 squared.
5 times 4.
So we have 27. 9 times 4 is 36. 27 minus 41. Lo and behold, guess what that equals? Have we seen that number before? Right there. Right there. So the remainder of using synthetic division at this C value is the same as plugging in the value in the equation. Which way is easier to do? Synthetic division is much easier because it's only multiplication, addition, multiplication, addition. This one, I got to do 3 cubed. Then I got to do 4 squared times 4. A whole bunch of other moving parts. So if you ever get in another equation, another class or whatever, and you're asked to find, you're given a function, asked to find that, don't plug it in the equation, put it in synthetic division and fix it that way. It's much faster. So what do we ask? So we just ask the remainder. The remainder is 14. Let's look at B. The same function. X cubed minus 4x squared minus 5. Find me the remainder of this equation.
You're saying instead of plugging in two or X. Where did you get three from the last one?
What's the first thing I did?
Oh, you saw it first, okay.
You have to first find your C value, which is
Okay.
C value is the X, not the equation. So we have to set this equal to 0 and solve for X. So that's my C value.
Oh, instead of putting in -2 for X in the function and solving it, you can just do synthetic.
I could do synthetic division, where it's X cubed, X squared, X, and a constant. So it's 1, -4, 0, -5. -2 times 1 is -2. -2 plus -4 is -6. -2, -6 is +12. -2 times 12 is -24. That's your remainder. And that would be exactly the same value we got if we did this. We know this answer is going to be -29. So far, so good. I mean, it's a pretty powerful tool.
Your way to do this,
This is these ways. Instead of plugging it inside there, we're taking this into pieces. Synthetic division, the remainder theorem, is going to help us try to find solutions. Because if this was 0, if that was 0, then we know that X plus 2 is a factor of that. Let me show you. Let's say we had X squared plus 6X plus 8 over X plus 2. Let's use synthetic division. So first step, take the denominator, set it equal to 0. Oh.
then what do we do?
So we have X equals -2. So our synthetic division, the highest exponent is X squared, X, and see, I like to put those up there so I know what I'm looking at. 1, 6, 8. So -2 times 1 is -2. 6 minus 2 is 4. -2 times 4 is -8. And here's the beautiful thing about it. So this tells us the remainder is 0, which tells us what? X plus 2 is a factor of that. So we know that X squared plus 6X plus 8 is X plus 2. This is the other factor. This is the constant. This is the X. So it's X plus 4. That's the other factor. So if you have a remainder of 0, you don't have to go back to this one anymore. You can just go back what's in the equation. That's the beautiful thing about synthetic division. It saves us tons of time, which is what we're going to talk about now, factoring things. So we're going to talk about the factor theorem. The factor theorem says suppose f of x is a polynomial function then x minus c is a factor of our function if and only if, that's if and only if f of c is equal to 0. What this says is the remainder equals 0. So it's actually two parts you're looking at. It's a polynomial function where that's a factor and the remainder is 0. Those are the two statements that theorem brings out for us. Let's look at an example. Our f of x is equal to 2x cubed minus x squared plus 2x minus 3. Are these factors? Of our function? Okay, again, now the theorem tells us that we're supposed to take our equation, if it's a linear equation in synthetic division, what it's saying is take your equation, set it equals 0, and solve for c. Then it's telling us plug this back into the equation and see if it equals 0.
Oh, okay.
That's what it's telling us.
I was gonna ask you, I was all like, if you weren't gonna do a synthetic division, how
You-
would you find out if there was a factor?
Actually, that's what I said earlier here. If you notice, these, if we did synthetic division, we got negative 14, or if we plugged it in there, we got negative 14. These are the same values. It doesn't matter. You can use either one of these things. You can find your C value. Once you find C, you can either do synthetic division or plug it in there. They'll give you the same answer.
What I'm saying though, if you didn't know what the remainder was by doing synthetic division and you only plugged in your C to the equation, and then you got negative 14, how would you
Find the factors? Well, that's a good point. Then if this gave it to be 0, then we know that x equals 3 as a solution, which means that x minus 3 is a factor.
Oh,
That's the first factor. This equation, you need 2 more. It's supposed to have 3 factors.
okay.
That's why this method isn't that good. The synthetic division, if that was a 0, then we don't have to use this equation. That's the constant x and x squared. We use this quadratic formula. So like this one here, let's first see. I really hesitate doing it, but we have to, just for giggles and grins. So we have to do 1 cubed is 1. 1 times 2 is 2. 1 squared is 1 plus 2 minus 3. So 2 plus 2 is 4, negative, so this is 0. Okay, that all that tells us is it tells us that x minus 1 is a factor. Whoop-de-doo. But
So
that we still need 2 more. which really sucks. But so what do? Once we find it's a factor, then we come over here and do synthetic division. 2, -1, 2, -3.
So if your highest degree is 3, like that,
Mm-hmm.
then you have to do both methods to find all the factors, or can you find all 3 factors through just synthetic division?
Synthetic division, we're going to learn that that's going to be the only tool we're going to use. This just tells us, is this a factor? Yes or no. That's all it tells us. It doesn't go any further. Synthetic division, if the remainder is 0, then we know it is a factor. It also tells us what the remainder is. So the first number comes down. 1 times 2 is 2. 2 minus 1. 1 times 1 is 1. So we know that x minus 1 is a factor. We know that x minus 1 is a factor. Now we only have to look at this.
0 resembles the x minus 1.
Yeah, this one tells us that x equals 1 is a solution, which means that x minus 1 is a factor.
Okay.
Now, this is the only equation we have to look at now. So now we can find the other values by using if we try to factor it too. What signs go in there? Yes, this one says they're both the same. They're both going to be positive. So we go 2 times 3 is 6. What times what equals 6? When you add them, you get 1. Try again. 3 plus 2 is not 1.
So it's 6 and 1.
6 plus 1 is 7.
Oh.
So we can't factor. So we got to use the quadratic formula. Using, this is A, this is B, and that's C. So we have -1 plus or minus 1 squared, 4 times 2 times 3. You see why? -1 plus or minus 6 is 24. 1 minus 24 is -23. So that's the reason we couldn't factor it. Because 2 of our answers are complex conjugates of each other. Yes.
So from 2x squared plus
From here to this one? Because once we figure out one of the factors is x minus 1, We did synthetic division, doing all this stuff. If you get a remainder of 0, then this is your remaining polynomial, which means this equation here, we know that we have a factor of x minus 1, and the remainder part's going to be x squared plus x, 2x squared plus x minus 3, or plus 3. So, and remember from algebra that if you have an imaginary answer, they have to come in conjugate pairs. Radicals and imaginaries have to come in conjugate pairs. Even though we have to have 3 answers, only 1 real solution, 2 imaginaries. Which means our graph will look something like this. Because we only have 1 real solution and the other 2 are somewhere out in some quadrant. So let's do the same thing with x plus 2. So we have b, x plus 2. So we got to set that equal to 0. This finds my c value. And then what the theorem says is if I plug that into the equation, my remainder, it's either going to be 0 or a number. And the only number I want is 0. If it gives me anything else, I can't use it for anything. So I use synthetic division. 2, -1, 2, -3. -2 times 2 is -4. Negative is positive. 2 times 5 is 10. -24. So x plus 2 is not a factor of f of x. Yep, that's all I was asking is find. It says just find whether the function has a factor of those guys. It's either yes or no. So far so good?
I think I have a question.
Yes.
Remember on example 1? When you did the percent division and you got -14.
And then I plugged it into the equation, I got -14.
But on the remainder, what did you do with higher? What did you do with the 1, -1, -3 again? I remember you did something like.
Well, I said in example here is if this was 0,
So you
then
did-
this would be the remainder function I have to deal with. Yeah, because I know I'm supposed to have 3 solutions. If this was 0, then I know that's one solution.
So that you actually did something.
No. I just use a hypothetical because they're not going to be so kind. Theorem, the number of real zeros. We know how many solutions we're supposed to get, but let's figure out how many real zeros we're going to get. A polynomial function. Did I give you? I think before you leave, remind me. I think I have the packets to give you off of this chapter. A polynomial function cannot have more real zeros than its degree. Yeah, let's go down to all the theorems that they're making us talk about. But yeah, it's duh. So I look at the highest exponent, that tells me how many. But it's the most. Does it have to have that many? No. Does it have to have any real numbers? Any real zeros? The trick question. Does a polynomial function have to have any real zeros? If your degree is even, you can have whatever n is, or you can have no. But if you have an odd degree, it has to cross at least once. Because if it was 5, if we had x to the 5th, what are the possibilities? Let's see here. X to the 5th. We can have 1, 2, 3, 4, 5 solutions. 1, 2, 3, 4 solutions. 1, 2, 3 solutions. 1, 2 solutions. 1 solution, but we have to have at least 1 solution. Because remember, if it's not a real solution, what kind of solution is it? Imaginary. And imaginaries have to come in what kind of grouping? Conjugate pairs. So we have to have 1 real solution and all the imaginaries have to come in conjugate pairs. So if it's an odd exponent, then we know we have to have at least 1 real solution. And those examples proved it to us too. So that just tells us how many solutions we can have. I should put are possible. Because the way it sounded, number of real zeros, it's going to tell us exactly how many we're going to have. No, these are a number of possibles. So if it's an even degree, we can have anywhere from n to 0. If it's an odd, we can go anywhere from n to 1.
Wasn't it the n plus 1, n minus 1? For finding zeros for odd or even degrees? Wasn't that the rule? If you had an even degree, it was, didn't know how many zeros, it's n minus 1.
Oh, no, that's the number of vertices.
Oh, that one.
Yeah, because if you look at this, if our degree is 5, then we know we can have at most 4 vertices.
Oh,
What does Descartes' rule of sign tell us? Do you remember that from algebra? Tells us the number of positive and negative solutions. Let me look for an example here. Well, I could do those using those we just talked about. So let's look. Example 2 we had was this: 2x cubed minus x squared plus 2x minus 3. We'll do that. Actually, let's start even easier than that.
I have a question.
What?
What if it gives you a function where your leading term didn't have the highest exponent? You just have to.
Then you have to rearrange it. Yeah, always. This should be always the first step is make sure it's decreasing order of exponentials. Because you typically want to see the first one left side to be your highest exponent, because everything else, to be honest with you, is not necessary. So it's not going to help us much. Let's look at this one. What are the solutions to that equation? How do we figure out the solutions in this one? Can we factor it? Is that positive? We have both of. So when we solve them, we get -4, -2. So we know our solutions, we have 2 negative solutions. So from this, Descartes' rule of sign for positive solutions. We look at the number of sign changes. X squared plus 6x plus 8. This is positive. Is that a sign change? Is that a sign change? No changes. Yeah, so we get 0 positive solutions.
Just points along the x-axis.
Yeah. Those are when we talk about solutions, those are the x-axis and intercepts. To find the number of negative solutions, now we have to set it up. We have to change all the x's to negative x. Negative x squared, that stays positive x squared. Negative and positive is a negative. Is that a sign change? Is that a sign change? So we can have 2 or 0 negative solutions. Why is it 2 or 0? Because what if one of the answers was imaginary? Then automatically the other one had to be imaginary, had to be a conjugate of it. So it'd be 0. So you always have to take consideration that the answers could be conjugate pairs or radical pairs.
But wouldn't you know anyways, because the highest degree is 2.
But all we know is we have 2 solutions. We don't know if they're real or imaginary.
Oh, okay.
So this says that we can have, all this tells us is be careful. We can have 2 negative solutions or we have no negatives that could be imaginary.
Oh, okay.
And that's it. That's all it tells us. It doesn't tell us anymore. That's what, let's look at this example. Let's see what that tells us. So f of x is equal to 2x cubed minus x squared plus 2x minus 3. So the positive solutions, how many sign changes are there? Is that a sign change?
Yes.
Is that a sign change?
Yes.
Is that a sign change? So we can have 3 or 1 positive solutions. How about the number of negative solutions? So before we do that, we have to look at change all the x's to negative x. So since that's an odd exponent, that means it's going to be that. This is even, so the negative cancels. This is an odd, so it changes its sign. So how many sign changes do we have here? Is that a sign change?
No.
No. Is that a sign change? That, so all we know, we have no sign changes. So no negative solutions. Because there's no sign changes. So what does this mean? We can either have positive, negative, or a conjugate pair. The degree of this one is 3. So according to this, we can have 3 positives. That means we have no negatives and no solutions. Well, we know we have no negatives. If we have 1 positive, that means we have to have 2 conjugates. Oop, this should be 3. Because we know that we have no negative solutions. If we have 1 positive, then we have 2 conjugates. If we have no negatives, we have 3 positives. We have no. So these are the possibilities. Doesn't tell us anything further than that. It just tells us how many we can have. So we look at, these are the possibilities we have. Let's look at another example. Here's our polynomial. F of x equals x to the 7th, or 3x to the 7th, minus 4x to the 4th, plus 3x cubed, plus 2x squared, minus x minus 3. So what's the degree of this polynomial?
7.
Which means we have to have at least 1 real solution, because it's an odd degree. So tell me how many positives and negatives I'm going to have here.
And
One,
3.
2, 3. So it could be 3 or 1 positive solutions. Because remember, you also always have to factor in conjugate pairs. That's why you subtract by 2. Whatever you have, keep on subtracting 2, you can't anymore. If it was 8, then we have 8, 6, 4, 2, 0. You always have to factor in what are the, so keep on subtracting 2 until you can't do it anymore. How many negative solutions? So basically now, when we put the negative sign in here, if it has an odd exponent, it's going to change the sign of the coefficient. If it has an even, so this one's going to be negative 3x to the 7th minus 4x to the 4th minus 3x cubed plus 2x squared plus x minus 3. Because only the odd exponents, I change the coefficients. Because when I put a negative in there, it's going to change the sign. We have 1, 2. So 2 or 0 negative solutions.
So would you figure out how many solutions you are? You said you subtract 2 from that?
Right. Yeah, once you figure out how many you have, you keep on subtracting 2 until you can't do it anymore.
Okay. And that's your or.
Right. So positive solutions, negative solutions, non-real solutions. The degree is 7. So we can have 3 positives, 2 negatives, which means how many non-reals do we have to have? 3 plus 2 is 5. How many more are we missing? 2. We could do 3 positives, no negatives, So how many non-negatives do we have? Okay, now I can go with one. If I had one positive and two negatives, how many am I missing here? Because it has to equal 7. If I had one positive, 0 negatives, then I would need 6 of those.
So
Those are the possibilities I'm going to have.
either for this example, for positive 3 or 1, it's not like 3 or 1 or 2 or 1.
Because if I have 3 positives, then it's one of these two. But if it's not 3, then I have to take into consideration the conjugate pairs. So I subtract 2, which gives me this one. So if it was 5, then I have 5 or 3 or 1. Keep on going down until you can't go any further.
Oh, okay. So for every one you subtract 2,
Right.
that's another.
That's another possibility of conjugate pairs.
Okay.
So yeah, and so you see now the more of those happens, your possibilities become greater. Which if you see this, that means you're gonna have a lot of hard time working on this stuff because look how many non-reals. That means there could be conjugate pairs, there could be radicals, there could be complex numbers. Because if you have 2 plus radical 5, then you have to have 2 minus radical 5. If you have 2 plus 5i, then you have to have 2 minus 5i. They have to come in conjugate pairs. Because your final answer cannot have radicals or imaginaries. Let's look at the next example. Oh, so far, so good. You realize we're going through an entire chapter of algebra of polynomials in an hour. And it's the hardest part of algebra. Oh. The rational zero theorem. This is the theorem now, because up until now, we haven't been concrete on anything. It doesn't tell us how many we're going to have, exactly how many. It doesn't tell us which ones you're going to have. It just tells us that they're going to exist. Now we're going to start narrowing it down. Because right now, if we have a polynomial, any polynomial you give me, and I ask you to factor it out, there are infinite number of possibilities you can put in there. Do they always have to be integers? No. They can be fractions. They can be decimals. They can be anything. What the rational zero theorem does is it goes down from infinity and breaks it down to a smaller finite set. And then from there, we use Descartes' rule to see how many positive, how many negatives we're going to have. So our entire process is trying to make it smaller, smaller, smaller. So here's the rational zero theorem. Let f of x be a polynomial function of degree greater than 1. Because if it's equal to 1, then there's nothing to do. It's a linear equation, only has 1. Or it has to be higher. If it's equal to 1, that's a no-brainer. We're done. It's a linear equation, set equals 0, and you're done. What was that? Let fx be a polynomial function of degree 1, and it looks like this. F of x equals a n x to the power n, a n minus 1 x n 1, a n minus 2 x n minus 2, A1, X1, A0. So that in itself is telling you you should always put it in decreasing order. Oh no. Well, anyway, I don't need that. Remember I said earlier, the only parts that are important are the leading term and the constant term. Because the leading term dictates the shape, the size, the direction. What does the constant tell us? It tells us the y-intercept. That's it. We'll call that P. Let's call it Q and call this one P. No, let's call this one P. Because I'm saying is, I like it this the P and Q because it's alphabetical. But you look at more textbooks, they're going to have the rational zero theorem is this. The factors of P and the factors of Q. So what is P? What is Q? The factors of A sub 0 over the factors of A sub n. And it's the plus or minus of each one of those. So here's an example. I'm filling blanks. What is this trying to do? The connection of these two, of where the fixed point is of the y-intercept and the leading coefficient, their ratio defines the dimensions, the size and shape of this graph. The quotient of those two, or possibilities, will now dictate exactly how many times it crosses the x-axis and where the values are. That's what this is telling us. The further you change these, the more either the wider it gets, the more degrees you have, it'll increase or decrease the number of zeros you have. Now, these will give us a large set, because whatever we get for these, we have to double it because it's plus or minus, but it's going to be smaller than infinity. For example, f of x equals 2x cubed plus 11x squared minus 7x minus 6. What can you tell me so far about this polynomial? How many zeros are we going to have?
One or zero.
At most 3.
Oh,
Because the degree tells us the number of zeros. The maximum number of zeros. We know that. So we know our degree is 3. How many positive solutions are we looking at? Yeah, because there's only one sign change. How many negative solutions are we looking at? So for the negative solutions, anywhere it has a negative exponent, change the sign in front of it. Two. Here's 1, 2, or 0.
or every negative exponent, you change the sign.
Right. Any odd exponent. Because if I put a negative number in there and I raise it to an odd number, it becomes negative. So all the even ones just cancels out. So I only change these two. So we have 2 or 0 negative solutions. Descartes' rule of signs and the zero product principle. What's going to be our rational zero? So the top number is always the last one, which is 6. And the bottom number is always going to be the first number, the leading coefficient. I want the possible factors. So what can 6 factor out into? 1 times 6 or 2 times 3? 2 can factor out into 1 and 2 only. So we have 4 on top, 2 on the bottom. 4 times 2 is 8. 8 times 2. So we're going to have 16 possible answers to choose from, which is a lot less than infinity. Each one of these that I'm going to put down are going to be positive and negative. So I'll start with 1. 1 over 1. 1 over 2. That's it for that one. Then 2 over 1. Then 2 over 2. Then 3 over 1. Then 3 over 2, right. And then 6 over 1. And then 6 over 2. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 total times 2, so they're plus or minuses. So these are possibility of plus or minus 1, plus or minus 1/2, plus or minus 2. This is 1. 2 over 2 is 1, so I don't need that anymore. Plus or minus 3, plus or minus 3/2, plus or minus 6. 6 over 2 is 3. I have that already. So now these are my possibilities. All of my zeros, my real zeros, have to come from that list. One, two, three, four, five, 6. So now I narrowed it from infinitely many numbers to 16. Now I'm down to 12. I can go even further. Since I know I only have one positive solution, once I find a positive solution, I don't have to try any more of those. This tells me I only have one positive. Once I find my positive solution, all the other ones I don't have to try because it's done.
I remember now.
All right, so let's look at our rational zeros are 1, 2, 3, 6. 1, 2, 3, 6. 1/2. 3/2.
Oh, yeah, I remember. So, and then you just went from left to right, you just tried the first one, if it doesn't work out, you go to the second.
Yeah,
so on
and
so forth.
our function that we're dealing with is 2x cubed, 11x squared, minus 7. So I start off with 1. So I'll take positive 1 and negative 1.
I remember doing this and like, it was like, I think maybe on a few, they made it the very last number and I'm just like.
Yeah,
oh,
they
come
always
on.
do that. Yeah, so here's my x cubed, x squared, x, and my constant. So let's see if 1 is a solution, which you're right, because of that, probably is not going to be. So bring the first one down. 1 times 2 is 2. 11 plus 2 is 13. 13 minus 7 is 6. I was wrong. So x equals 1, which tells us that x minus 1 is a factor.
I think that's when I was doing these, instead of starting from the beginning, I just started like in the middle and then worked my way back.
You're right. Now, since we have only 3 possible solutions, if it was higher, then instead of starting with -1 here, I would start with +1 again. Why? Because what if you have a multiplicity? What if it's a repeated number? So you start off with the one you just did. I start off with 1 again and see, because this is the equation we have to deal with now. We're done with that one. We just have to see if it fits in this one. So no more. So we know that x equals 1 is one solution, so that's the factor. But since we only have three solutions, this is our positive one. So what does that tell me? I don't have to do any more positives up here. All my positives are taken care of. I just have to check my negatives. But since this is what I have left, I can either try to factor it or quadratic formula. And this tells you A, B, C. So it's -13 plus or minus 13 squared minus 4 times 2 times 6.
No regular factor, 12 and 1, x squared plus 12.
Well, let's see. If we were going to do a regular factor, so we have 2x and 2x. They're both positives. 2 times 6 is 12. So what times what is 12? When you add them, you get 13. It'll be much easier.
I try to avoid the quadratic equation.
But now, if you're going to this method here, what can you factor out of these equations? Can you factor anything out of this one?
6.
2. X plus 6. And that one I can't do any further. So these are my factors. Whatever I factor out of there, whatever's left is my factor. So my factors are x minus 1, x plus 6, 2x plus 1. Which tells me my solutions. +1, -6, -1/2. And remember what Descartes' rule of sign says? We're going to have 1 positive and 2 negative solutions. Where's the next example? Anybody lost yet? I'm trying not to. Let's look at another example. F of x equals 3x cubed plus 8x squared minus 7x minus 12. You haven't written one thing down yet. And we're gonna build up from here too. So what can you tell me about this? The degree is 3. Positive solutions?
1.
Yeah, it's only one sign change. Negative solutions? So it's going to be negative 3x cubed, 2x squared, 7x. Yeah, so it's 2 or 0. The rational zeros are q over p, I should say. So it's 12 over 3 plus or minus. So what are the possible factors of 12? Three times 4, 2 times 6, 1 times 12. And then 1 and 3 on the bottom. 6 times 2, we're going to have 24 possibilities.
I don't get that part. Where's the?
Because you have 6 on top, 2 on the
Oh,
bottom. So
okay.
combinations are 6 times 2. So they're going to be 1 over 1, 1 over 3, 2 over 1, 2 over 3, 3 over 1, 3 over 3, 4 over 1, 4 over 3, 6 over 1, 6 over 3, 12 over 1, 12 over 3. And these are all plus or minuses. 1 over 1 is 1. This is a 1, so I have to worry about it.
Next, move the 2/3.
This is 3/3.
Two.
I was gonna put that at the end. Because I'm put the real ugly ones in the back. 6 over 3 is 2. I already got that. 3 over 2 is 3, 12 over 3 is 4. I already got that. Yeah, so typically I put my fractions in the very back. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. We have 18 possible answers to go through. Everybody okay so far? So now we start with positive and negative 1. Our polynomial is 3, 8, negative 7, negative 12. Seven. So it's not 1. How about negative 1? So it's negative 3, 5. Yes. So x equals negative 1. So x plus 1 is a factor. Well, now since we have our degree is 3, we can just use that polynomial there. But remember, yeah, you're right. Since we have one real negative, we have to have another one. Because the only reason it would be 0 is if we had 2 complex numbers. So since we have one real negative, has to have another real negative, which means we have to have a real positive too. So now we just have to worry about this equation. 3x squared plus 5x minus 12. Let's see if we can factor this one out. 3x, 3x. This is a negative, that means the signs are opposite. One's positive, one's negative. The bigger number will be the positive sign. 3 times 12 is 36. So what times what equals 36? When you subtract them, you get 5.
Six, no. 4, and 3, 1, and 9, 4, 9, 4, 9.
4 and 9. 4 times 9, 9 minus 4. So the bigger number gets the positive, so that's 9, and this is 4. Can we factor anything out of the first? It leaves us x plus 3. Get rid of that. So these are our last factors. So these are our factors are x plus 1, x plus 3, 3x minus 4.
The x plus 3 would be your other negative.
Yeah, so this one would be a -1, a -3, and a positive 4/3. So those are your answers. So everything's zeroing out like it's supposed to. But so far, these have been pretty easy. Degree 3. Let's jump into the next one. It's degree 5. F of x is x to the 5th minus 7x to the 4th plus 19x cubed minus 37x squared plus 60x minus 36. So what's our degree? How many positive solutions?
5.
5 or 3 or 1. Remember, you always have to subtract 2 for the complex conjugates. How many negative solutions? So we have negative x to the 5th, negative 7x to the 4th, negative 19x cubed, negative 37x squared, negative 60x, 0. Because remember, all the even ones are already negatives. So change all the signs of the odd exponents, they're all negatives. So that is helpful. Because now when we do the rational zero theorem, we don't have to do the negatives, we just do the positives. So 36 over, and even better, our leading coefficient is 1. So we have no weird fractions. So we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, 8 times 4, 6 is 32. No. So those are possibilities. 1, 2, 3, 4, 6, 9, 12, 18, 36. And remember, we don't have to do the plus or minus anymore because there aren't going to be any negatives. Well, let's begin. 1, -7, 19, -37, 60, -36. -7 plus 1 is -6. 19 minus 6 is 13. 37 minus 13 is 24. 60 minus 24 is 36.
Forgot why you divide by 1.
What do you mean divide by 1? This one? Because here? Because that's my solution. That's the first one in my number set.
Oh, okay. Oh, so if you were going on, okay, my bad.
The first one I try is 1, it's supposed to be positive, negative. +1, that doesn't work. I try -1. Then +2, -2, negative, positive. I keep on going this way till I find all of them. So we know that my first factor is x minus 1. Okay, so I start off with 1 again, see if it's a multiplicity. 1, -6, 13, -24. Once you get a 0 remainder, you don't have to go back to the original equation. Just go back to what you have left in your equation. Right, 2. 1, -6, 13. I mean, keep on trying it yourself because I could be wrong. I could make a mistake, which has been known to happen a lot. We're running out of space here, and we're running out of numbers.
Three, you said 3 times -3 is bottom one.
Good catch. And that just happened the ones I needed. Very good catch. Thank you. Well, I know 4 is not going to work because since it didn't work on this one, it's not going to work for this other one. But now all I have to do is use this equation from here on. So I know that x equals 3 also. So x minus 3 is another factor. So now I gotta try 1, -3, 4, -12. -3, -12.
So we have total positive solutions is either, if it's not just like either like, for example, like 5 or 1, I don't know if that makes any sense, 5 or 1.
No, it's either 5 real ones, nothing else, 3 real ones, and then 2 imaginary, or 1 real one and 4 imaginary. But since we have 2 possibilities, it can't be 1. We have 2 of them already solved. So it can't be 1 real solution. So it has to be 3 or 5.
So if when going through all the rational zeros, and say you find 3, you still have to keep going just in case.
Yeah, you have to find all 5. You have to find all 5 solutions.
But there may not be 5 solutions.
Well,
There just be
no,
3.
no. As we get to, it's once we get to the third one, then we'll be left with the quadratic equation. Then we use the quadratic formula, and that's going to tell us either it's going to be solution or a rational or imaginary.
Okay.
One, -3, 4, -12. Bring out a 1. 3 minus 3 is 1. That's not going to work. The next number is 6. 1, -3. There's something in a second. What if it was another 3? So we have another 3. So we have a multiplicity for the x plus 3. So we have, so far our solutions are x minus 1, x plus 3 squared. Now all I gotta do is look at this equation. This equation says it's x squared plus 4 equals 0. X squared equals -4. X equals plus or minus 2i. So we have x plus 2i, x minus 2i. Those are my solutions. So these are my factors. Once you get once you get to 3 parts, it's much easier to solve from there. I found my 3 real solutions. Nothing else was working, so I tried 3 again. Remember, always try it just in case you have multiplicity. I just forgot to do it again. And then I had x squared plus 0x plus 4 is x squared plus 4 set equals 0. So my polynomial f of x to the 5th minus 7, x to the 4th, plus 19x cubed, 37x squared, plus 60x minus 36, factors out to be x minus 1, x plus 3 squared, x plus 2i, x minus 2i. And there we have 3 real solutions, 2 imaginary. There's my 5 solutions.
Oh, okay.
The same one. Right. That's it for that. What do y'all think? Bring back some bad memories from algebra?
A lot of work, but I can do
It is, but think about what you think of the equation you were looking at. It's a 5th order equation. And we were lucky as the first one was a 1. That really saved us a lot of time. No, not any fractions at all. But that's how we do it. So the first thing we did was figure out what's our degree, how many positives, how many negatives, then look at the rational zeros and start plugging in. And we're done. Yes.
Why don't we divide by 2? 5 or 3 or 1?
Good question. Because you notice in this case, we're supposed to have 5 solutions. If one of them is an imaginary solution, they have to come in conjugate pairs. So they have to come in pairs. So since we know we have to have 5 possibilities, but if we have 2 imaginaries, then we're going to have 3 real solutions. Or we can have 4 of these can be imaginary. That's why we always we get rid of 2 for each imaginary pair that's possible. We don't know which one's which, but once we got the second answer, we know it couldn't be that. Once we got the third answer, we know it. So, I mean, it could be only 3 because we couldn't get any more. All right, that starts your vacation. Hey, this is one of the first times I let you guys out early. If you call 2 seconds early.